The first close-up image has been captured by Hawaiian astronomers, with scientists not knowing where it originated. Now eventually they identified this item, formerly known as 3I Atlas, as a visitor from another galaxy. The first alert flashed from a Hawaii observatory, a trajectory that is hyperbolic. That means one thing: it's not from around here. Almost immediately, data confirmed the object named 3I Atlas was an interstellar visitor. As of now, these are extremely uncommon. It's only the third one ever. There's, you are aware, 1.5 million near-Earth objects, approximately 35,000 asteroids. But as telescopes around the world focused in, the real shock began. The object is made up of a chemical mixture that scientists barely understand, and it's getting a very, very close encounter with Mars. This first-of-its-kind upcoming event looks promising, a scientific mystery and a spectacle that nobody has ever seen before. The Gallery of Cosmic Shooting, the only one from the week of September 12th to 18th, shatters every previous record for close encounters. Get this: at least 28 near-Earth objects travel through the Moon's orbit. That is triple the previous weekly high. Many people are obsessed with keeping an eye on these things. You can see why. Most are small, in the 25 to 80-foot range, the kind that could break apart in our atmosphere, or if they're a bit bigger, explode with the force of an atomic bomb, just like the Chelyabinsk meteor did in 2013 over Russia. But two of them, FA-22 and RJ-2, are much, much larger. We're talking 400 feet here, each one being large enough to warrant global attention. Every single finding flashes across the screens of survey teams that work continuously. You have Hawaii's Pan-STARRS and the Atlas Project, which sprang up all over the world, and the brand new Vera C. Rubin Observatory in Chile's Atacama Desert. The data comes in from these, processed by automated telescopes and sophisticated catch-and-release software, even the faintest, fastest-moving blips of light against the blackness of space. The pace is absolutely relentless. New objects are flagged, their orbits calculated, and the degree of their threat evaluated, frequently within hours of their initial appearance. The Rubin Observatory, just a few months into its operational phase, is making a contribution. A flood of fresh data. Its massive camera covers huge swaths of the sky, picking up things that would have gone by otherwise, completely ignored a year ago. The most shocking fact is how statistically unlikely this all is. The models used by astronomers to make predictions of these occurrences, adjusted for our better detection abilities, put the odds of witnessing more than 25 moving objects inside the Moon's orbit in a single week at less than 1 in 500. It's supposed to happen once every 10 years. An occurrence rather than something that appears on a random Tuesday. Even with our shiny new technology, the September surge stands out. It's a tight cluster of objects that seems to defy the usual random collection of asteroid approaches. Some experts are quietly making hypotheses about strange orbital resonances or maybe a hidden breakup that occurred far away in the asteroid belt that sent a shotgun blast of debris our way. However, many have overlooked the timing. This cosmic barrage is taking place as soon as something truly foreign enters our solar system. On social media, these crazy theories are fueled by numbers. Graphs are passed around showing a spike in activity that doesn't look sharp enough to be coincidence. Some call it an arranged pattern and a warning shot from the universe. In the scientific community, the mood is calmer, but no less alert. All close passes are recorded, analyzed, stored, and fed into a global planetary defense system that is only as strong as its latest detection. For a brief, tense window, the world's sky catches the eye. What then if one of these massive rocks were not just a narrow miss? Not from around here. While Earth is busy avoiding cosmic fire, a different drama is taking place a little bit further away, close to the orbit of Mars. The Pan-STARRS telescope in Hawaii flags an object on July 1, 2025, taking a path that is too fast. For astronomers, that term is a siren. It means the object is moving too fast to be captured by our sun's gravity. It's not a planet in our solar system. It's accurate. An interstellar visitor, the third and final one ever proven, and it earns the designation 3I Atlas. The first two, Oumuamua and Borisov, were scientific sensations. Oumuamua was an odd, cigar-shaped item that tumbled end over end, while Borisov acted and looked more like a conventional comet, just one from a different star. But 3I Atlas, also catalogued as C2025N1, was distinct right away. The issue? You don't know how bizarre its approach is. In contrast to its course, everything that is kept on the minor planet center's archives, which contain data on hundreds of millions of solar system bodies, it's coming in at a steep angle in relation to the planet's plane. And it's not just passing through the outer solar system. It's diving right into the thick of things on a course that will bring it frighteningly close to Mars. What a lot of people missed in the initial excitement of its discovery was the sheer energy of its approach. It's moving at an alarming rate of more than 60,000 mph relative to our Sun. This is not the steady course of an Oort cloud comet long gone. This is the confident stride of a thing that traveled for millions, if not billions, of years across the icy, gloomy void between the stars. And where it's going, the moment is spectacular for a brief time. The red planet. The encounter is set for October 1st, a date now circled on the calendars of scientists from NASA, ESA, and all significant space agencies. The very nature of 3I Atlas raises mind-boggling questions. Where did it come from? What kind of star system could have ejected an object with such a bizarre structure? And how many more of these interstellar ghosts are drifting through our cosmic neighborhood, silent and unseen? Its path seems almost intentional, not in a coercive manner, but in a manner that seems way too perfect. It appears as if the universe decided to send us a gift of mystery, enclosed within a cosmic delivery, and deliver it directly to the front door of the one planet besides Earth that we are actively exploring. On the surface, like the rovers Perseverance and Curiosity, and orbiters like the Mars Reconnaissance Orbiter are being repurposed. Their sensors and cameras are being turned away from the Martian surface and in the direction of the coming visitor, which has transformed our robotic explorers into a front-row audience for a show like no other in the sky. The 3I Atlas approach is a stark reminder that our solar system is not an isolated island. It's a wide-open environment that welcomes visitors to cosmic shores of which we have only dreamed. This object is a physical piece of a different region of the galaxy, and learning it is like getting a free sample of a world we may never reach. Its composition wasn't just strange, it was something that shouldn't exist, a recipe for a new universe. As the most powerful telescopes in the world concentrated on 3I Atlas, the data they sent back was, to put it mildly, baffling. The first spectra captured by the Very Large Telescope's X-Shooter instrument in Chile revealed the comet's coma, the fuzzy cloud of gas around its nucleus. A regular comet from our solar system? That coma is dominated overwhelmingly by water vapor sublimating from ice as the sun warms it. However, not 3I Atlas. Its coma was largely composed of carbon dioxide. Then the James Webb Space Telescope aimed its golden eye at the visitor and confirmed the numbers. The facts were jaw-dropping. The comet was erupting more than 300 pounds of carbon dioxide gas each and every second. The quantity of water vapor? A mere 15 pounds per second. That's a ratio close to 21. In our solar system, that ratio is flipped. Water is the emperor of comets. Here it was merely an afterthought. This suggests 3I Atlas formed in a part of its home star system that was extremely cold, significantly lower than the areas where our own comets formed. It was created in a location where carbon dioxide ice was much more common compared to water ice. However, the bizarreness persisted there. The most shocking fact was yet to come. Using high-resolution spectra, a strong signal of atomic nickel streaming from the coma. That's not unheard of, but it's usually accompanied by its chemical cousin, iron. Clearly, in most cosmic bodies, nickel and iron are like cosmic twins. Where you find one, the other is almost always present in a predetermined ratio. However, in 3I Atlas, the iron simply wasn't there. It was below the telescope's detection threshold. Nickel without iron. It's a chemical pattern so rare that it has been mentioned in only a few other strange things. It's like finding a car made of aluminum but with no steel. It defies the established laws of cosmic metallurgy. The rumors began to spread. What type of star is it? What system produces such objects? Perhaps it came from a place rich in nickel-containing materials, where carbon could bond with organic molecules that were later broken down by sunlight. Or possibly during its extensive journey through interstellar space, cosmic rays selectively removed the volatile iron compounds, leaving the nickel behind. There is no one model that fits all the data. It really is a first-of-its-kind puzzle. Then in mid-August, another surprise. The Mars Reconnaissance Orbiter, looking up at the sky in ultraviolet light, suddenly caught a dazzling flare. The Atlas had an outburst, an eruption from its nucleus that doubled its brightness in less than 36 hours. Amateur and professional astronomers on the planet observed its tail, clearly divided into multiple components, with streams of dust fanning out in different directions. These violent, episodic outbursts weren't being driven by jets of water, as is typical in our comets. They instead pointed to supervolatile carbon dioxide ice pockets just below the surface, erupting explosively as sunlight penetrated the nucleus through new cracks. This was not just a passive visitor. It was lively, active, and utterly alien. It was carrying messages from a solar system recipe completely different from our own. And it was about to give us the most intimate view yet. Would it survive the encounter, or would it paint the Martian sky with dust from space? Red Planet meets Intruder. On October 1, 2025, a fleet of human-made machines is prepared at Mars. On the surface, the Perseverance rover stops its geological survey in Jezero Crater. The potent Mastcam-Z and SuperCam instruments normally used to analyze Martian rocks are angled toward the heavens. In orbit high above the thin pink atmosphere, the Mars Reconnaissance Orbiter (MRO) and the MAVEN spacecraft alter their trajectories, preparing to get an unparalleled view of the guest from beyond space. The world is taking it in through the eyes of our robotic proxies, hundreds of millions of miles away. Now, Atlas is a breathtaking view in the Martian sky, far brighter than any star. Its huge carbon dioxide coma glows with a ghostly white light, and its bizarre tail of multiple reeds stretches across a vast portion of the sky. Mars has such a thin atmosphere, less than 1% the density of Earth's, that the view is exceptionally clear, unhindered by weather or pollution. This is a first-hand account of a cosmic event on massive proportions. The crucial moment is the closest approach. The comet is expected to pass within 50,000 kilometers of the surface of Mars. That's an incredibly close shave in cosmic terms, about 1/5 of the distance from Earth to our moon. The gravitational pull of Mars at that range, though weak compared to Earth's, will be important. Scientists are watching for any sign that the planet's gravity is tugging on the comet's nucleus. They are searching for new jets of gas, telltale signs of stress bursting, or even the terrible likelihood that the nucleus, already weakened by its violent outbursts, could fragment completely. If 3I Atlas splits up, it would be a scientific goldmine, but a disaster for the comet. A breakup that would create a cloud of pristine interstellar material, the raw ingredients of a world from another star system, scattered right in front of our instruments. The orbiter's spectrometers would become a first-of-its-kind look at the comet's heart, analyzing the composition of its core without the cloudy appearance of the coma. For a brief period, the skies of Mars would fall into a meteor shower like no other, tiny, inflamed fragments of an alien world igniting in its lackluster atmosphere, a downpour of shooting stars from another star. Down on the surface, Perseverance doesn't simply watch. Its sensitive microphones are listening. The entry of even small fragments disintegrating into the atmosphere could create faint sonic signatures, supplying information on the density and structure of the Martian air. The vehicle is also using its weather sensors to look for changes in air pressure or temperature, subtle indications that a large amount of gas and dust from the comet is being added to the planet's environment. We just saw a visitor from another star. What other secrets are hiding in the night? Did this incident alter your perception of our position in the universe? Like and subscribe.